So in this example, we're going to practice identifying chiral carbons and then naming them as either R or S. So let's start off with this molecule right here. If we look carefully, the only two carbons that have 4 different groups is this carbon and this carbon. And the reason is because on this carbon we have a hydrogen going back, on this one we have a hydrogen going back. And if we look at them, we have this giant group right here for this carbon. You have this carbon and this carbon. Although they are connected in a ring, this one has a double bond while this one doesn't. So it's as if 2 different groups. And so this is chiral, and the same thing goes to here. We have a methyl or bromine, this giant group, and a hydrogen. So let's start naming them. Well, with this one, we're going to try to prioritize which carbon. So on this one right here, it's connected to 2 different hydrogens and 1 carbon. So 2 hydrogens and 1 carbon. On this one right here, we got 2 hydrogens and a carbon. And on this one, we got 1 hydrogen, and then you have 1 carbon, but because of the double bond, it's as if it's connected to 2 different carbons. So it's as if this one's connected to 2 carbons and this one is connected to 2 different carbons right here. So this is going to be number 1. Now, if we're going to compare these two, if we go to the next biggest group, so the next carbon right here, this one's connected to a bromine while this one's connected to a carbon, and then a ghost carbon because of the double bond. But because this is connected to a bromine, this is going to be higher priority. So this is 2, this will be 3. So we're going this way, that's R. So this carbon is R. Now let's do the same thing for this next one. If we have a bromine, that's going to be clearly number 1. Then we have a methyl, and then this giant group right here. Now obviously this giant group is going to be prioritized higher than this methyl, especially because this one only has 3 hydrogens while this one has another carbon, and then so on and so forth. So this is going to be 2, 3. So we're going to go this way. So this is also R. So both these carbons are R. Now let's look at this molecule right here. If we see, we're going to see some stereochemistry right there, but look at that. There's 2 different methyls, or they're actually both exactly the same methyl. So they're both the same exact type of group. So it's this carbon right here, even though it might look like it's chiral, it's not. And then we're just looking around for any 4 different groups. And we see this carbon right here. It has a methyl, a hydrogen, a nitrile group, and then this giant ring. So this is actually chiral. So let's start prioritizing. Well, we have a carbon, and a carbon. And we're going to ignore the hydrogen for now. Now with this carbon right here, it's actually triple bonded to the nitrogen. So it's as if this carbon has a bond to a nitrogen, a bond to a nitrogen, and a bond to a nitrogen. While meanwhile with this carbon right here, it has 1 carbon, 2 carbon, and then double bond. So it's as if this carbon is connected to 1, 2, and then 3 carbons. So if we compare these two, nitrogen has a higher atomic number. So this is going to be number 1. This is going to be number 2, while comparing to this just methyl, it's going to be 3. So we're going this way. Now you would say S, but then the hydrogen is actually pointing towards us. So it's flipped, and it's actually R. So this is right here is R. Now let's start looking at this next molecule. We have a carbon right here that looks like it has 4 groups. It has an ethyl, a methyl, this giant nitrogen ring, and then this other nitrogen ring that has a carboxyl group. So this is chiral. And then with this carbon right here, it has an ethyl or an ethanoic group. You got this ring, you got this carbon that's attached to a nitrogen, this carbon that's attached with a double bond in the rest of the molecule, and then a hydrogen that we cannot see. So we're going to draw that. So these two are both chiral. Now how do we prioritize them? Now we're going to look at this one. We have an ethyl, a methyl, and then these 2 things. So methyl is the largest group, the smallest group, so we're going to ignore it. If we're looking at the immediate groups, you have a carbon, and a nitrogen. So this is going to be 1. And then if we compare these 2 carbons, this one's only connected to 1 carbon, while this one's connected to 1, 2, and then a third ghost carbon. So this is 2, this is 3. We're going to go this way, so it's R. Now if we look at the next group right here, so I'm going to use a different color. We have the immediate groups. We're going to ignore hydrogen. We're going to look at the immediate groups. We got a carbon, and a nitrogen. Nitrogen has the highest atomic number, so it's 1. So then now we're going to compare these 2 different groups, what they're attached to. So we have this group right here, which is attached to 1 carbon and 2 hydrogens, while on this one, it's attached to 1 carbon, 2 carbons, and then a ghost carbon because of the double bond. So this is going to go higher priority than this. We're going to go this way. So that makes it S.